Penguin Random House Audio presents The Genius of Birds. This is the author, Jennifer Ackerman. For Carl, with all my love. Introduction. The Genius of Birds. For a long time, the knock on birds was that they're stupid, beady-eyed and nut-brained, reptiles with wings, pigeon heads, turkeys. They fly into windows, peck at their reflections, buzz into power lines, blunder into extinction. Our language reflects our disrespect. Something worthless or unappealing is for the birds. An ineffectual politician is a lame duck. To lay an egg is to flub a performance. To be henpecked is to be harassed with persistent nagging. Eating crow is eating humble pie. The expression bird brain for a stupid, foolish, or scatterbrained person entered the English language in the early 1920s because people thought of birds as mere flying, pecking automatons with brains so small they had no capacity for thought at all. That view is a gone goose. In the past 2 decades or so, from fields and laboratories around the world, have flowed examples of bird species capable of mental feats comparable to those found in primates. There's a kind of bird that creates colorful designs out of berries, bits of glass, and blossoms to attract females, and another kind that hides up to 33,000 seeds scattered over dozens of square miles and remembers where it put them months later. There's a species that solves a classic puzzle at nearly the same pace as a 5-year-old child, and one that's an expert at picking locks. There are birds that can count and do simple math, make their own tools, move to the beat of music, comprehend basic principles of physics, remember the past, and plan for the future. In the past, other animals have gotten all the publicity for their near-human cleverness. Chimps make stick spears to hunt smaller primates, and dolphins communicate in a complex system of whistles and clicks. Great apes console one another, and elephants mourn the loss of their own. Now birds have joined the party. A flood of new research has overturned the old views, and people are finally starting to accept that birds are far more intelligent than we ever imagined, in some ways closer to our primate relatives than to their reptilian ones. Beginning in the 1980s, the charming and cunning African gray parrot named Alex partnered with scientist Irene Pepperberg to show the world that some birds appear to have intellectual abilities rivaling those of primates. Before Alex died suddenly at the age of 31, half his expected lifespan, he had mastered a vocabulary of hundreds of English labels for objects, colors, and shapes. He understood the categories of same and different in number, color, and shape. He could look at a tray holding an array of objects of various colors and materials and say how many there were of a certain type. How many green keys, Pepperberg would ask, displaying several green and orange keys and corks. 8 out of 10 times, Alex got it right. He could use numbers to answer questions about addition. Among his greatest triumphs, says Pepperberg, were his knowledge of abstract concepts, including a zero-like concept, his capacity to figure out the meaning of a number label from its position in the number line, and his ability to sound out words the way a child does, t. Until Alex, we thought we were alone in our use of words, or almost alone. Alex could not only comprehend words, he could use them to talk back with cogency, intelligence, and perhaps even feeling. His final words to Pepperberg as she put him back in his cage the night before he died were his daily refrain: "You be good. See you tomorrow. I love you." In the 1990s, reports began to roll in from New Caledonia, a small island in the South Pacific, of crows that fashion their own tools in the wild and appeared to transmit local styles of toolmaking from one generation to the next, a feat reminiscent of human culture and proof that sophisticated tool skills do not require a primate brain. When scientists presented these crows with puzzles to test their problem-solving abilities, the birds astonished them with their crafty solutions. In 2002, Alex Koselnik and his colleagues at Oxford University asked a captive New Caledonian crow named Betty, "Can you get the food that's out of reach in a little bucket at the bottom of this tube?" Betty blew away the experimenters by spontaneously bending a piece of wire into a hook tool to pull up the little bucket. Among the published studies, tumbling from scientific journals, are some with titles that lift the brows. Have we met before? Pigeons recognize familiar human faces. The syntax of gargles in the chickadee. Language discrimination by Java sparrows. Chicks like consonant music. Personality differences explain leadership in barnacle geese. And pigeons on par with primates in numerical competence. Bird brain. The slur came from the belief that birds had brains so diminutive they had to be devoted only to instinctual behavior. The avian brain had no cortex like ours, where all the so-called smart stuff happens. Birds had minimal noggins for good reason, we thought, to allow for airborne ways, to defy gravity, to hover, arabesque, dive, soar for days on end, migrate thousands of miles, and maneuver in tight spaces. For their mastery of air, it seemed, birds paid a heavy cognitive penalty. A closer look has taught us otherwise. Birds do indeed have brains very different from our own, and no wonder. Humans and birds have been evolving independently for a very long time, since our last common ancestor, more than 300 million years ago. But some birds, in fact, have relatively large brains for their body size, just as we do. Moreover, when it comes to brain power, size seems to matter less than the number of neurons, where they're located, and how they're connected. And some bird brains, it turns out, pack very high numbers of neurons where it counts, with densities akin to those found in primates, and links and connections much like ours. This may go a long way toward explaining why certain birds have such sophisticated cognitive abilities. Like our brains, the brains of birds are lateralized. They have sides that process different kinds of information. They also have the ability to replace old brain cells with new ones just when they're needed most. And although avian brains are organized in an entirely different way from our brains, they share similar genes and neural circuits, and are capable of feats of quite extraordinary mental power. To wit, magpies can recognize their own image in a mirror, a grasp of self once thought limited to humans, great apes, elephants, and dolphins, and linked to highly developed social understanding. Western scrub jays use Machiavellian tactics to hide their food caches from other jays, but only if they've stolen food themselves. These birds seem to have a rudimentary ability to know what other birds are thinking, and perhaps to grasp their perspective. They can also remember what kind of food they buried in a particular place, and when, so they can retrieve the morsel before it spoils. This ability to remember the what, where, and when of an event, called episodic memory, suggests to some scientists the possibility that these jays may be able to travel back into the past in their own minds, a key component of the kind of mental time travel once vaunted as uniquely human. News has arrived that songbirds learn their songs the way we learn languages, and pass these tunes along in rich cultural traditions that began tens of millions of years ago, when our primate ancestors were still scuttling about on all fours. Some birds are born Euclideans, capable of using geometric clues and landmarks to orient themselves in three-dimensional space, navigate through unknown territory, and locate hidden treasures. Others are born accountants. In 2015, researchers found that newborn chicks spatially map numbers from left to right, as most humans do. Left means less, right means more. This suggests that birds share with us a left-to-right orientation system, a cognitive strategy that underlies our human capacity for higher mathematics. Baby birds can also understand proportion and can learn to choose a target from an array of objects on the basis of its ordinal position, third, eighth, ninth. They can do simple arithmetic as well, such as addition and subtraction. Bird brains may be little, but it's plain they punch well above their weight. Birds have never seemed dumb to me. In fact, few other creatures appear so alert, so alive in fiber and faculty, so endowed with perpetual oomph.
Sample complete. Ready to continue?